It is 2 hours UTC. Welcome everybody again to Astronomy Daily Live. This is a live daily stream coming to you, bringing in a circle of friends to share and talk about a common passion, which is the science of astronomy. And one of the cool things about astronomy is that it pretty much covers everything. So always lots to talk about. I'm going to make sure that my Linux machine is not running live. It is. Okay, got that out. Okay, got the chat up. Gonna go over here, get my smartphone running so I can monitor the live stream, make sure it is actually running. You know, I you know, relatively speaking, I'm not really having any technical problems. I'm not having sort of, the technical problems that I see other podcasts have when they sort of worry too much about it. I wonder if that worry is sort of spilling over into the equipment and actually making it not work. There's something to that, I think. So hey, everybody. Hope everybody's doing well. Hope your last 24-ish hours was was a nice one. Things are good here. Wow, it's getting really warm here down in southeastern Arizona in the United States. It's a little tiny bit unusually warm. I think we're getting it just froze up. Oh, there we go. Getting really close to 90 degrees Fahrenheit here. So yeah, it's getting a little early. The uh, the thing that it may still happen. It's getting a little less of a possibility of this, but we could have a late freeze. And what happens is, okay, in this part of the world, there are certain fruit and nut trees that um, that will go into flower because it's so warm, right? They'll go into flower, they'll start flowering and everything else, and then we'll have one below freezing night, and pow, just pow, it just knocks everything out, right? So don't know if that's going to happen this year. Most years, unfortunately, that happens to a certain extent. We have to, if we want to have our peaches and plums and um, almonds and that, we really, if there's going to be a late freeze, we have to do something. We have to protect the trees in some way. I never have. I don't quite have an orchard yet, but it's definitely something on the list. I want to have a few peach trees. I want to have a few plum trees. We can't really grow citrus out here. It does get too cold for that. But apples grow really well out here. Pecans, pistachios. I've got farms of those all around me out here. So, but yeah, it's pretty darn warm today. So don't mind. I like the heat. In fact, I like everything about this place. So there, you'll never ever hear me complain about the climate or the weather or anything else. First of all, I find it absolutely amazing, and and two, I like it all. I like every single bit. The only thing that you might you might hear me whine a little bit, is about snow. Okay. And the only reason why I whine about snow is because I've had enough of snow. I've had enough of it. The cool thing about snow here, just like the cold, is that it doesn't last. It doesn't last. So I actually remember. I think it was the first year. It's the first year, or maybe the second um, winter that we moved here to this location. It We had a freak snowstorm that dumped like 4 inches on the ground, and that actually stayed for more than a day. So that was quite extraordinary. By the next day, it was almost gone, and I think the day after that it was completely gone. So that's the one cool thing about snow here. So yeah, all right. Enough about climate and weather, although those are related to astronomy in a big way, especially if you're ground based, right? Now, if you're space based, you also have to worry about weather, but you have to worry about space weather, not Earth weather, and that's a completely different uh, thing altogether. So, but yeah, all right. So let's get off of talking about the weather, which is what everybody talks about, and it's like, oh, let's talk astronomy. So, um, you know, this live stream is for new people. It's for the amateur community. It's for the pros, right? So it's for everybody. Everybody. I definitely like to get some pros in here to just either talk about what they're currently working on and just let them have the floor. Just talk about what problems they're having, what what questions they're trying to answer. Not an interview. Although there probably will be Q&A, but not an interview. More just look, just talk, just talk. We're in a circle of friends here, and we want to hear what you are working on, and that not only goes for the pros, um, but for the amateurs too. There's a lot of very active um, amateurs who are doing just absolutely amazing things. I'd love to have them come on and just talk, right? Just talk about their thing. So I'm thinking about ways that I can reach out um, to those communities a little bit more. And yeah, what it's going to take, I think, is just for me to sort of remove the timidity that I have about, you know, doing that kind of thing, because it's an absolute fact, and I've experienced this multiple times. So it shouldn't be a hang up, but it still is to a certain extent. But the fact of the matter is that unless you ask for things, you're very unlikely to get them. If you just sit back in the corner and hide, you're really not going to get much of anything at all, because that's just not how the universe operates, right? The universe is like a mirror, right? And so if you give and give and give and give, that's going to reflect back, and that's how things seem to work. So yeah, I just need to find ways to um, to do that, and it's been done so many times. Hey there, Tom. Hope everything's well with you. Thanks for coming in. Tom was one of our regulars here, so it's always awesome to see you, Tom. Um, so yeah, you know, as I said, my primary thing is to get better and better and better every single day. And you know, that's I understand that that isn't totally achievable. That you know, it's more like get better and then flatline and then get better and then flatline. You know, that's how it works. So, but yeah, I definitely like to get, you know, some folks in here just to talk about what they're doing. You know, the work they're doing as far as the pros go, either what they're doing now, or you know, if they want to talk about a paper that they um, wrote, you know, just had published. I think that would be really fun, really cool. So, all right, tonight it is the dihydrogen oxide again, for no particular reason. I'm not observing um, tonight, but it just seemed the right thing to do. This H2O, dihydrogen oxide, is one of the most, I keep saying one of the most, it is the most amazing molecule in the universe. It's just it's astonishing, and it's everywhere. It's in the sun. We've detected H2O in the atmosphere of the sun, superheated, 6,000 degrees H2O on the sun. So cheers. And I've got in this mug, I we calculated this a couple of live streams ago. In this half mug or so, I've I've got about 10 to the 25th molecules in here. So there are more H2O molecules in this little sample than there are stars in the entire universe. So cheers. Mm, nice batch. Nice batch. So yeah, last night's observing went pretty well. The seeing was pretty nice. The flats and the other calibration data wasn't quite as good as what I would want, but it's certainly workable, certainly doable. The flats. So just really quick. So the dynamic range of my CCD camera is 16 bits. Okay, so that means that um, um, when the CCD detects a a flux, okay, it's going to convert that flux into a number that goes between 0 and 65535. Okay, 16 bits, 2 to the 16th. Okay, and so at very low light levels, the CCD behaves in sort of a funny way. It's called nonlinear. And at very high light levels, it does exactly the same thing. It's sort of funny, right? So, but in the intermediate, you know, between about a third and 2/3 or so, is sort of prime, right? Is like really nice. And you know, those numbers aren't exactly right. You know, I mean, it's probably more like, you know, between a fifth and 4/5, something like that, right? Um, and so what I want to do with my flat fields is I want to set the exposure time such that my maximum flux is about 2/3 or 3/5, 4/5, something like that of maximum. So if maximum is 65,535, I'm aiming for about 50,000, between 40,000 and 50,000. Now, uh, last night I was getting in the 30,000s and the 20,000s. So, and not quite as good as what I want. Uh, is it good enough? Yeah, it's fine. It's still in the linear regime, so no problem at all. Seeing was really nice. Although I started with M46, and M46, if you're an observational astronomer, you know that it's starting to get pretty low on the horizon. So I'm looking through a lot of air that way. So I'm kind of curious to see what the results of that is. And then I did two sort of random fields, sort of, pointing the telescope higher up, looking through less air, where the seeing was a little bit better. And field number A. So I took 100 images of um, M46, 100 2-second images, um, and then uh, I sort of randomly pointed it up and found a relatively rich field of stars, at least a few stars. Um, this this time of year isn't very nice for um, open clusters. It's galaxy time, so we're looking towards the uh, towards the galactic pole. So the north galactic pole, and that's out of the galaxy. It's not sort of across the disk, but actually 90 degrees to that disk. So there just aren't the clusters or anything like that visible. So I just have to just sort of randomly point and slew around a little bit, see if I can find anything at all. And I did. Unfortunately, stupid me, um, on the second data set, I did not note the right ascension and declination of where I was pointing. So I have no way of being able to go into the Gaia database and pull out those those stars in order to compare them. So it's like, I realized this after I tore everything down, and it's like, so I'll still be able to do an evaluation of the precision, but I won't be able to make any kind of evaluation of the accuracy. So that's how it goes. Stupid. Um, I look quickly at um, M104, hoping that there would be sort of some bright stars in the field of view, but there were only a couple, and it's like, you know what? I'm not gonna uh, spend a lot of time um, trying to do a photometry on a galaxy on an extended object yet. I'm looking at point sources. I'm looking at stars at this point. If this project that I have in my head actually gets going, then of course um, um, extended objects like galaxies and nebulae and all that are on tap. But yeah, so I was out, a few hours or so. Got cold. It is the desert here. So as I said, we've been getting into the mid 80s Fahrenheit during the day, and it was definitely in the low 40s, which, okay, relatively speaking, that's not all that cold. But I had to bundle up. I had to put on a couple of layers, put on a hat, you know, all of that. When you're out there just basically sort of sitting, doing nothing at all, even a little bit of cold is just um, uh, you want to try to be as comfortable as you possibly can. So no big deal. But yeah, so that's that. So let us move on. I've One of the cool things about having a daily live stream is that as far as news goes, as far as um, astronomical news goes, I can usually scoop everybody else, right? And that isn't why I do it. That's a result of having a daily thing. And I actually see that as a compliment, complementary to the other astronomical podcasts that can, you know, take those same stories, those same papers, and go into a little bit more depth. But the cool thing is that if you've heard it here first, and I just sort of, skim over it, just skim, the with the broadest of strokes, you sort of get a little bit of an idea. So when you hear it again and they go into more depth, I actually think that at least I hope that sort of adds to your appreciation of the topic and just helps you understand a little bit more because I can sort of plant that seed, right, and I can get it to sprout, right, and then you can at least have it in your head. You can go look at the paper, you can think about it, and then when you hear it on the weekly space hangout or deep astronomy or um, the slew podcast, any of those, uh, space news, any of those, it you'll already have that sprouted seed in your head, and I'm hoping at least that that kind of thing is appreciated. As a result, I scoop everybody too. Cheers. So I posted on my Discord. I'm going to try this one more time too. I posted over on my Discord. I'm going to, let's see. Oh, that's why. Okay. iTunes was trying to do another update. At least iTunes asks, you know. I'm going to share my screen here. And it doesn't look like that's coming up. Let's go over to my Discord. My Discord server, my link to my Discord server is down in the description. So if you haven't joined, feel free to. You're very, very welcome there. You can post things, we can have conversations, et cetera there. And I try to keep up with that during the day. So anybody post anything there, I've got different channels, so you can sort of choose uh, which channel you think is most relevant to the post that you want to make. It's arbitrary. I don't care. You know, I don't care. But I was going through archive.org as I always do, and I came across this paper from yesterday. This paper from yesterday. Now I knew about these some uh, some videos made by amateur astronomers have shown these bright flashes on Jupiter. Um, and they actually even say that in the first sentence, flashes. And I'm going to get into this paper a little bit here, but the primary thing that I want to say here is that I think that calling them impacts, I think that's really jumping to a conclusion that I don't know. I don't know. I mean, we're seeing flashes. We're seeing flashes that last 1 to 2 seconds. Okay, so is it an impact? Is it an object that is impacting the planet and we're seeing it burning up, or is it something else? I mean, there's another kind of thing that flashes for 1 to 2 seconds, and that's lightning. So I don't know. I mean, these these guys have said, look, these are impacts. Period. Done. Done deal. That's sort of the basis of of this whole um, paper, is that they've said um, we've seen flashes. They are uh, um, impacts, and so and then they get into the characteristics of the impacts, based on how bright they are, how large of an object does it have to be to create that amount of energy. Um, then they get into how often should these things actually be seen, et cetera, et cetera, et cetera. So you know, I think that because they're seeing a flash, they're jumping to a conclusion of impact, and I don't buy that. I don't really buy that. It's just a flash. It's just a flash. So I don't know. Could be anything. Could be anything. Let's remain skeptical and open-minded, right? So here's the paper. Just came out yesterday. I've got a slow internet today. The squirrels are running slowly. I always imagine these little squirrels in their little round cages inside of the computer, just running feverishly, right, with their little round things, spinning really, really fast. And yeah, that's sort of the image that I have when I think about what's happening inside of these computers. Uh, so, they reference Shoemaker-Levy 9 and the impacts that were observed, uh, supposed impacts. I actually observed those. I was there. The actual events sort of happened on the backside of Jupiter, so there were no really direct observations, but flashes nevertheless were seen, which means they were quite extraordinary. They were quite bright, and of course there were debris fields as well. And at least in this paper, they're saying that those spots remained visible for weeks to years. So yeah, I mean, and uh, Shoemaker-Levy 9, I actually saw before the impact when it was, uh, I would say maybe a month or two before impact, when it was, it's it was the most unusual comet that I'd ever seen. It was um, cigar shaped, right? Because it was not just one um, nucleus. It was 13 or 14 or 20 or something like that. I forget exactly how many there were. Um, but you know, and they were spread out. So through a telescope, I actually looked at it through um, the 61-inch telescope up on Mount Bigelow, north of Tucson. So yeah, I looked at it through a 61-inch telescope, and you could see the individual nuclei, not all of them, but it was definitely cigar shaped, which you know, comets usually don't look that way. But yeah, that was quite an extraordinary event there. So you know, impacts happen, right? For sure, for sure. But to say that these flashes were impacts, oh, I don't know. I don't know. So here, as I said, I believe all the detections of these flashes were done with video cameras. Um, just so happened to be pointing at the right place at the right time, and as you can see, nice bright flash, nice bright flashes. This was June 3rd, 2010. Here's August 20th, 2010. Here's one of the moons down here too. Here's September 10th, 2012. Now this is an unusual one. I'm not quite sure if this is because of the post processing or what, but if we zoom in on this a little bit, I don't know about you, but you know, I'm seeing structure there. So that could be, that very well could be a post-processing artifact. You know, these flashes are most likely point sources, and if they're trying to, you know, uh, sort of make things as clear as possible, maybe this is part of an airy ring, so it's possible that is actually just a single thing, and because, as I said, of post processing, maybe it's an error ring. But if it isn't, and there might be some details in the paper about that. If it isn't, I'd like to understand a little bit better how the impact theory explains these structures. So I don't know. See, I don't know. But anyway, so that one, let's see, that one's September 10th of 2012. Sorry you missed it. I missed it too. So here's March 17th, 2016. Another another impact that has a little bit of structure to it, you see? And again, you know, is this post processing? Is this an artifact of post processing? Or is it something else? And if it's something else, it's like, how do you explain a structure if you only have like a 10-meter diameter object impacting Jupiter? I don't know. I don't know. I mean, you know, I don't know. I'm just throwing things out. That's the skeptic in me. Um, you know, questioning things, questioning. So there's another supposed flash as well, May 26, 2017. So they've only observed, at least in this paper, they're only um, they're only talking about 5 impact events. Let's see, is there a list? Yeah. Okay. So here are the date and the UT time of the events, who observed them, what size of telescope they were, what kind of detector, you know, what kind of camera, any kind of filtering. You know, most of these, as you can see, are just, you know, regular old video cameras that have the RGB Bayer format. Um, the duration of the flashes, they're very consistent. Yeah, well, moderately consistent. You know, 3 observers looking at the same event have, you know, slightly different um, um, duration lengths. Yeah, I don't know. Here they're looking for, you know, debris fields. Some follow-ups, you know, were done soon after these, and yeah, you know, you can see that there's some little, you know, maybe like little splashes, right? So yeah, maybe it is an impact. I don't know. I want to see what's this one, the one with the funny thing. That was September 10th. They go into some detail here. They talk about each one. I think they do at least. Oh, maybe they don't. They just have a more detailed analysis on summary of previous impacts. 2 months later. Yeah, okay. I don't see any details about that particular one. They they did a nice analysis of the last 2 that were done on March 17th, 2016 and May 26th, 2017. Observations by a um, variety of amateur astronomers were obtained between 10 minutes and a few rotations after the impact. None of these observations showed any debris field on the surface of the planet. Okay. Um, and yeah, I was reminded of this Planetary Virtual Observatory and Laboratory, PVOL, which is awesome. I forgot about that. Uh, um, so they compare these to known impacts. What they did, I think, you know, I just sort of scanned this paper in the last hour-ish or so, Tom. So I'm not too much on it. Um, they they did seem to do a comparison between impacts on Earth, right? So yeah, we'll just have to look at the paper in more detail. So they have light curves. So you know these are videos. So you know they're running at a certain frame per second type of a thing, and you can see that you know this is time and this is intensity, right? And you can see that there's a, you know, there's a flash there for sure. So this is raw light curves of the impact. They're calling it an impact on March 2017. And you can see that the shape, you know, is there's a little bump here and there's a little bump here, and then there's a peak, and then it oh stop, and then it, you know, diminishes quite rapidly. Oh stop! Hey, this mouse driving me crazy tonight. Here, I'm going to keep my hand over here. So, you know, here they're talking about a flash of 1.15 seconds. Here, a flash of 1.3 seconds. You know, where you set these lines is going to matter how long the actual flash is. Um, so here's, you know, some zoomed in images. The resolution is poor because, you know, it's a video camera, and you know, seeing isn't great, and blah 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 blah. They don't have any calibration data, so you know there's no way, you know, to take out any flat fielding or dark or anything like that. Um, Although they try, you know, they're trying. Here's some more light curves. Even see down here, I noticed that my time is getting going. So these folks are interested in trying to make observations of these flashes slash impacts themselves. And, you know, these kinds of things are depressing to read, but that's how it goes. They say in the past 5 years, we have observed Jupiter over 20 different campaigns over an average of 2 nights per campaign, acquiring about 2 hours of data each night. So they've obtained about 40 hours of data. Um, uh, oh, okay. So an accumulated observing time of 80 hours. I don't know how they get that, but okay. Um, and they have not seen a single one. They haven't seen a single one. So, you know, when when you're ready for it and you're waiting for it, it just doesn't happen. And this goes back to what I'm talking about in terms of the three elements of success, right? Three elements of success are: you have to be at the right place at the right time, and you have to be ready, right? You have to be able to grab, be aware that there's a golden ring. Then you have to grab the golden ring and you have to hold on to the golden ring. So so far they have not seen the golden ring, um, much less grab onto it. But no, I mean, look, what you're going to have to do, guys, what you're going to have to do is you're going to have to set up a telescope to continuously look at Jupiter, okay, run video, record video every single clear night, which means that you need to set up multiple telescopes in multiple locations and, uh, you know, um, to eliminate the possibility of weather impacting you. The cool thing about having multiple observations of the same events is that you get more data that way. So yeah, I think this needs to be done, and can't be all that hard or expensive. Come on, people. Um, So yeah, they should set this up and do it, because really, that is the only way. That's the only way that you're going to see these things. Let's see. Zooming through this really, really quickly. This is just the number of images of Jupiter per month as a function of year. The green lines here are the dates of Jupiter um, oppositions. It's when Jupiter and Earth are closest to each other. That's sort of the optimal time to observe Jupiter, right? Is when it's at its closest and therefore largest. So let's see. Are there any conclusions here? Impact flux on Jupiter, consequences for the chemical composition and dust abundances. Here's a nice graph. I need to spend a little bit of time with this graph before I am ready to really talk about it, dive into it, because this is a prediction. This is actually they're using models to try to predict how many of these flashes they should see per year, right? And all these lines represent that, but it does go up to almost 1,000 per year. So I don't know. I have to investigate this a little bit more um, before I can really say much about it, because there's a lot of information here, much more than what I am able to cover in such a short amount of time with almost no preparation at all. So let's see. Uh, Summary of impacts on Jupiter. Predictions of impacts per year that leave observable debris fields. Um, so they're talking, and let's see, their detectability. Uh, okay, so yeah, for small ones, they're talking 1 or 2 a year. Medium-sized objects, a few more. Larger ones, a few more. So I don't know. Searches for debris fields left by impacts. The thing about observing a flash on Jupiter is that we can see half of the planet at the same time. So that you've got a 50-50 chance of seeing these. So that's pretty good, I think. Let's see. So the most uh, TN. I don't know what TN is. Tons, tons. I don't know. Masses, the cumulative impact rate of objects of this size range or larger is predicted to lie in the range of 10 to 65 per year, with only 4 to 25 being observable. So, yeah, well, if there are 4 to 25 per year, where are they? Where are they? I don't know. Pretty interesting work, though, and man, I think setting up a little telescope, right? Well, I need to stop sharing. Setting up a scope, you know, 2 or 3 or 4 inch telescope with a video camera, just recording Jupiter all night long. You can write some software to actually detect events. That's extremely easy, extremely easy. So you don't have to sit there and uh, watch the whole thing. You let the machines do it, right? And if something interesting happens, then the computer can alert the humans, and we can look at it a little bit more closely. I think something like that would be very, very cool. And hmm, interesting project. Interesting project. But archive.org is very, very awesome. Not only to get the scoop on the other podcasts, but it's to keep on sort of the bleeding edge, seeing what's happening in the astronomical world right now. And then the really, really cool thing about every single one of these papers is that two huge, huge, huge things. The first thing is that it's a launching pad. It's a launching pad into learning more about topics, right? Every single paper covers a whole bunch of topics, just tons and tons. Just that paper alone, right? We're talking about impact theory. We're talking about Jupiter. We're talking about populations of objects. um, just on and on and on. So it's a launching pad into learning about lots of other kinds of astronomical things. Um, and then the references is a history lesson. It's a history lesson. So, you know, every every reference refers to some kind of a topic, and that reference is work that has been done in the past, right? So you can go to the list of references at the end of every single paper, and you can find a history of that particular topic. Okay, you can find a whole paper on one sentence that is said in one paper, right? And then you can take that older paper, and it's going to have a bunch of topics and a bunch of references. And so you can go back and back and back and back and back. So it's just, I mean, every paper is like this. It's awesome. It's like it's it it's like school. It's like an astronomy lesson, and you can dive in as much as you want, and you can go back, look at the history of a particular topic. It's really cool. It's really cool, really fascinating, and I'm really running a little bit over the time that I want to go. I keep saying that I want to go between 30 and 45 minutes, and look, it is 2:51 UTC. So I think, this is me, right? I mean, I can talk astronomy all day, all night, because I love it. I've got the passion, and I'm glad that you all were here to share it with me again. This is a circle of friends getting together every single day. Now, you don't have to come in every day. If you want to, please come on in. But you can come in every other day, every week, every month, whatever it is. Stop on by. We're always happy to see return faces, new faces, anybody else. So spread the word about this. There is a very active astronomical community out there. And I think this kind of a format um, uh, is going to appeal to that. I'm looking for my core group, right? I'm looking for my core group. Where is my core group of 100 viewers, right? Where are they? Now I've got a little bit of a core group now, right? 2 or 3 or 4, right? That that is awesome. But I think my core group is a little bigger than that. It's a little bit bigger than that. I would say that my core group is maybe 100 or 200 or so. So I'm on a mission to find my core group. And the secret to the success is no secret at all, right? It's luck. Got to be at the right place at the right time. That's most of it. That's 90% of it. 90% of it. But the thing that makes the success work is that you have to be prepared. You have to be ready for that kind of an opportunity. And so that's what this is right now, is that I am preparing. I'm getting myself and the rest of this channel prepared for when that opportunity arises, or those opportunities arise. I will be able to recognize that golden ring, see it, and grab it. So I'm doing this for fun. This is fun. This is casual. It's and it's easy. It's easy. For me, there's no burnout. There's no anything at all. I'm sitting here every single night anyway, thinking about astronomy. So why not open it up, share the passion, everything else. Hit the thumbs up, hit the thumbs down if you don't like it. Whatever it is, I want a reaction. I want a reaction. Make some comments. down below if you want to be a panelist, right? This is a Google Hangout. So if I assume that if you want to be a panelist, okay, you can pop your head in here, or your icon, avatar, I guess is what it's called. And you can be on the panel and you can talk, and I can sit back and listen and watch. I think that that is what I really would would like. I'm more than happy to talk this entire time, but if somebody else wants to, hey, I'm going to provide the platform, and that's it. And then I'm going to step out of the way and let them have their say. So as long as it's astronomy, that's cool with me. That's cool with me. All right, I'm going to get out of here for now. Peace. Cheers. I will see you on the spin about 23 hours from now. We're going to do it all over again tomorrow, 2 hours UTC. Hey to everybody who is watching this not live. Glad you could watch it to the end. All right, I will see you tomorrow on the spin. Peace out and cheers. Bye.